everyone. Hello children, good morning. Till yesterday we have learnt about the rational numbers, but in today's session we are going to learn about the irrational numbers and definition of irrational numbers and their representation. And in today's session we will learn about what is an irrational number and what are the conditions for a given number to be called as an irrational number. Okay, let us start our session. Okay children, today we will learn about the irrational numbers and real numbers. Okay, let us recapitulate what are rational numbers. The number which is written in the form of p by q, where p, q belong to z and q is not equal to 0, is called a rational number. And the set or group of these numbers is denoted by the letter q. Okay, and it is represented as q is equal to p upon q, where p comma q belong to z and q is not equal to 0. Okay, example for rational numbers are 2 by 3, minus 2 by 3, 3 by minus 2, minus 1 by 2, 5 by minus 7, etc. Dash 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 dash. Okay, in the example written above, p and q are integers but q is not equal to 0. This is all about the rational numbers. But today children, we will learn about the irrational numbers first and then we will learn about the real numbers. Okay. Now look at the board children. Irrational numbers. Okay. Let us understand the definition of irrational numbers. Irrational numbers means any number which is not written in the form of p by q, where p and q are integers and q is not equal to 0, is called an irrational number. Okay, the set of irrational numbers is denoted by bar q or ir. Okay, example for irrational numbers are root 2, root 3, root 5, root 7, etc. Okay, and cube root of 2, cube root of 3, cube root of 5, cube root of 7, etc. Now children, we saw the definition of irrational numbers and the examples for irrational numbers. Okay, now let us see why this root 2, root 3, root 5, root 7, etc. are the examples for irrational numbers. And cube root of 2, cube root of 3, cube root of 5, cube root of 7 are examples for irrational numbers. Okay, see here, this is square root mark. This is also square root mark. I have written 2 under the square root mark. Then should we believe that any number written under the square root mark is an irrational number? Is one question. Let us look at the set of second examples. Okay, see here, this is cube root mark. This is also cube root mark. Here all are cube root marks, and I have written 2 under the cube root mark, 3 under the cube root mark, and 5 under the cube root mark, and 7 under the cube root mark. Then should we believe that the number written under the cube root mark are all examples for irrational numbers? No. Now let us see children why any number written under the square root mark is not an irrational number and any number written under the cube root mark is not an irrational number. Okay, see here children, there are certain conditions to call a particular number as irrational number. Okay, any number written under the square root mark is not irrational number. Okay, and any number written under the cube root mark is not irrational number. there are certain conditions to call it as an irrational number. Let us discuss what are those conditions. Okay, look at me, children. If square root of n is to be called as an irrational number, this n should be a prime number. Okay, this n should be a prime number and this n should be a positive integer. Okay, this n should belong to a positive integer and this n should be a prime number. Okay, and one more thing, this n should not be a perfect square number. Perfect square number means this number should not be written as the product of two equal factors. If it is, or if it can be written as the product of two equal factors and this number is under the square root mark, then this is not an irrational number. This becomes rational number. Okay, for example, look at square root of 4. The question is square root of 4 irrational number or rational number? Okay, square root of 4 is not an irrational number because square root of 4 is equal to, here the value of n is 4, right, and this is square root mark, and this 4 is written as the product of two equal factors. Okay, then square root of 2 into 2 becomes 2, but this 2 is equal to 2 by 1. Now 2 by 1 is in the form of p by q, where p is an integer and q value is 1, that is also an integer, and the value of q is not equal to 0. That is why, children, square root of 4 is not an irrational number. It is a rational number because square root of 4 is equal to 2 and that 2 is equal to 2 upon 1 is equal to p by q form, where p and q are integers and q is not equal to 0. Secondly, is square root of 81 an irrational number or not? See here, square root of 81 is not an irrational number because here this is square root mark and here the value of n is 81. N is a positive integer, but this 81 is a perfect square. Why is it perfect square? This 81 can be written as the product of two equal factors. Okay, that is square root of 81 is equal to square root of 9 into 9. Okay, so 81 is written as the product of two equal factors. That is why 81 is a perfect square. Now square root of 9 into 9 becomes equal to 9. This 9 can be written as 9 upon 1 and is equal to p upon q. Here p is equal to 9, which is an integer, q is equal to 1, which is an integer. Therefore p and q belong to z and q is equal to 1, which is not equal to 0. So, therefore q is not equal to 0. That is why, children, square root of 81 is equal to 9, 9 is equal to 9 by 1 and it is in the form of p by q, where p and q belong to z and q is not equal to 0. Therefore we can say square root of 81 is not an irrational number, it is a rational number. Okay, therefore, children, the first condition is the square root of n, if it is an irrational number, this n should be a positive integer and this n should not be a perfect square. Okay, if this cube root of n is an irrational number, okay, then there are conditions. That is, this n should be a positive integer and this n should not be a perfect cube. What is the meaning of perfect cube? Any number written as the product of three equal factors or three equal integral factors is called a perfect cube. Therefore, children, if any number written under the cube root is to be called as an irrational number, this n should be a positive integer and this n should not be a perfect cube. Let us see an example. Cube root of 8. Is cube root of 8 an irrational number or rational number. Okay. Cube root of 8 is not an irrational number. You may question me, sir, cube root of 8 is under the cube root mark. Therefore, it is an irrational number. No, it is not an irrational number. Let us see why. Because cube root of 8 is equal to, okay, cube root of 2 into 2 into 2. It means here the value of n is 8. And this n is a perfect cube. Why is it perfect cube? You can write this 8 as the product of 3 equal integral factors. You can write this 8 as the product of 3 equal integral factors. That is 2 into 2 into 2. Here 8 is equal to the product of 3 factors and all the 3 factors are equal. If any number is written as the product of 3 equal integral factors, then that number is called perfect cube. Here 8 is a perfect cube. Okay. Then cube root of 2 into 2 into 2 is equal to 2. Okay. But 2 is written as 2 by 1. Now it is in the form of p by q, where p and q belong to z and q is not equal to 0. Here p is equal to 2 and q is equal to 1 and q is not equal to 0 and p, q are integers. That is why children, cube root of 8 is equal to 2, which is rational number. Therefore, cube root of 8 is not an irrational number. It is a rational number. Okay. Let us see one more example. Is cube root of 125 an irrational number? No. Because 125 is a perfect cube. You can write this 125 as a product of 3 equal integral factors. Okay. Which are those equal integral factors? 5 into 5 into 5. Okay. Here 125 is equal to the product of 3 factors and all the 3 factors are equal. That is why 125 is a perfect cube. And cube root of 5 into 5 into 5 is 5 and 5 is equal to 5 by 1. Therefore, 5 by 1 is equal to p by q. Here p is 5 and q is 1, and where p and q are integers. Where p and q belong to integers and q is not equal to 0 here. Here the value of q is 1. It is not equal to 0. That is why children, cube root of 125 is equal to 5 and this is not an irrational number because cube root of 125 is a rational number. It is not irrational number. Is it clear to you? There is one more condition for a number written under the square root mark and cube root mark to call it as an irrational number. That is, under the square root mark, if any number is prime number, then it must be an irrational number. And under the cube root mark, if the value of n is a prime number, then also cube root of n will be an irrational number. Okay, let us see the examples. Children, in your previous classes you have learnt about the prime numbers. Okay, prime number is a number which has the factors 1 and itself. If any number is divided by 1 and itself, other than 1 and itself, if it doesn't have any factors, such numbers are called prime numbers. Okay, see here, under the square root mark there is 2, right? And this 2 is a prime number. That is why root 2 must be an irrational number. Okay, but let us illustrate. Let us show root 2 is an irrational number. Now let us take the example square root of 2. Some people may question me that, sir, square root of 2 is equal to square root of 2 upon 1, because any number divided by 1 is the same number. Therefore, square root of 2 is equal to root 2 upon 1. Now it is in the form of p by q, where p is root 2 and q is 1 and q is not equal to 0. Therefore, they may say that square root of 2 is a rational number, not an irrational number. Okay, but you are true. But look at the answer here. Square root of 2 is equal to square root of 2 by 1. It is correct. And that is equal to p by q. That is also correct. But where q is not equal to 0, that is also correct. and q is an integer, that's also correct. But is p an integer? No. Here the condition fails. Here p is equal to root of 2 and square root of 2 is not an integer. In the set of integers you will find, okay, minus 1, minus 2, minus 3 up to infinity, 0, plus 1, plus 2, plus 3 up to infinity. But you will never see square root of 2 in the set of integers. That is why here p is square root of 2, which is not an integer. That is why square root of 2 is not a rational number, it is an irrational number. Therefore children, root 2 does not belong to z and q is equal to 1 belongs to z and q is not equal to 0. But p is not an integer here. That is, square root of 2 is not an integer. Therefore, square root of 2 is an irrational number. Okay. According to the third condition, look at the first set of irrational number examples here. 1, 2, 3, 4. 4 examples I have given for irrational numbers. Here, square root of 2. Okay. Here 2 is a prime number. Root mark, but 3 is a prime number. Here, take square root of 5. Here 5 is a prime number. Let us take the example of square root of 7. Here 7 is a prime number. Therefore, under the square root, if prime numbers are written, then they will become examples for irrational numbers. Similarly, let us take second set of examples. Okay. Here, cube root of 2, cube root of 3, cube root of 5, cube root of 7, etc. Okay. Here, under the cube root you will see 2 as a prime number. Under the cube root you will see 3 as a prime number. Under the cube root you will see 5, which is a prime number. Under the cube root you will see 7, which is a prime number. That's why the second set of examples are also examples for irrational numbers. Hope children, today you learnt what are irrational numbers and the conditions for a given number to call it as an irrational number. Okay. Any number written under the square root mark is not an irrational number. The first condition is n should be a positive integer and secondly this n should be a prime number and this n should not be a perfect square. Okay. If any number under the cube root is to be called as an irrational number, the first condition is n should be a positive integer and n should be a prime number and n should not be a perfect cube here. And here the n should not be a perfect square. Okay. Now let us take a note. Here this is called 8th root of n. If you would like to call this number as an irrational number, here this is called order of the root, right? And here the order of the root is a. This a's value should be a positive integer and its value should start from plus 2, plus 3, plus 4, plus 5 and a's value should not be a negative integer. Okay. That is, a is called order of the root and this order of the root should be a positive integer and it should have the values from plus 2, plus 3, plus 4, plus 5. It should not be negative integer. And here children, the value of n, okay, the value of n should be a positive integer. It should not be a negative integer. And one more condition, if you would like to call this 8th root of n as an irrational number, the n should be factorized and the number of factors in n and the value of a should not be equal. Okay. That is, if this n is factorized and there are 3 equal factors and if the value of a is also 3, then it will not be an irrational number. If you factorize this n and the factorization of n has 5 equal factors and the value of a is also 5, then 8th root of n is not an irrational number. Therefore, we can say the number of equal factors in the factorization of n and the value of a should not be equal. If they are equal, then eighth root of n is not an irrational number. This is the one more very important condition to call a particular number as an irrational number. Okay, children? Here we can conclude that this is a general form of an irrational number, that is eighth root of n, and there are conditions. Okay, here n belong to a positive integer, and the value of n should not be negative, and the value of a, okay, should also be positive, and it should start from 2, 3, 4, 5. The value of a should not start from 0 or 1, but it should start from plus 2, plus 3, plus 4, plus 5. Okay, and here the number of factors in the factorization of n and the value of a should not be equal. Okay, children? Then only the eighth root of n can be an irrational number. Okay? So children, hope you all have learnt about the irrational numbers, definition, examples, and the conditions for the given numbers to call it as an irrational number. Okay? Hope children you have learnt about the irrational number and their representation in today's session, and the conditions for a given number to be called as an irrational number. Okay? Thank you for watching and see you tomorrow. Goodbye.